finish up this lesson that we were talking about in section 5.6, inequalities in one triangle. We already talked about the bigger the angle, the bigger the opposite side. So now we're going to talk about the next inequality. The next inequality is called the triangle inequality. Ladies and gentlemen, the triangle inequality basically just says that in a triangle, right, the sum of any two sides of a triangle must be greater than the length of the third side. If you need to pause this and write that down, you might want to at this point. Anyway, let's move on. So here's what I'm saying. If I have a triangle, suppose I have a triangle, 1, 2, 3. Please don't judge my triangles. I'm going to call this A, B, C. Here's what the triangle inequality says. I add up any two sides of my triangle. So if I said like the length of AB plus the length of BC, I know that has to be more than the length of the single side AC. Right? I could have also said the length of, say, AC plus the length of BC has to be greater than the length of AB. I can do one more relationship. Couldn't I say that AC plus AB, those two sides added together, must be longer than the third side, BC? Okay? Again, all it says is if I add any two sides together, that the sum has to be more than the third. Okay? So let's take a look at an example how we can use this. If I say, can I make a triangle from the given lengths? Well, what if I told you I had a triangle that had 3 as one line? Let's call it inches. 4 inches for another line, and 5 inches for another line. Well, if I take any two and add them together, listen, is 3 plus 4 greater than the third side 5? Well, that's 7. 7 is definitely greater than 5, so yes. If I added 3 plus 5, is that greater than 4? Again, yes. And then lastly, if I add 4 plus 5, is that greater than 3? Yeah, of course it is. In fact, the last two are kind of silly. I mean, take a look. Isn't 5 already by itself greater than 4? Right? And isn't, again, 5 and 4 both greater than 3? So yes, when you add them together, they are. In fact, the only two you really have to worry about are the shortest two compared to the biggest one. Are the two shortest ones greater than the biggest one? Okay? So, let's take a look. I'm going to give you an example now where you couldn't make a triangle. Suppose I have 4 inches, 7 inches, and 11 inches. What are my two smallest sides? Nameless man in the front?
4 and 7.
4 and 7. Well, if I add 4 plus 7 together, is that greater than 11?
It's equal to.
It's equal to. Thank you, gentlemen in the back. 11, is that greater than 11? No. So could I make a triangle out of these three lengths? No triangle is possible, right?
You have to write that.
And you're right, no triangle possible. Yes. Okay? So that's the use of the triangle inequality. All right. How about this type of problem? What if I do this? Suppose I said, in this example, I'm going to give you two lengths of the triangle, right? Given two sides of a triangle, find the range of possible lengths for the third side. Alright, so what if I gave you the length of 5 inches and 13 inches? Well, there's two assumptions that could happen here. I never told you who's the longest and who's the shortest, right? So, I know that I'm looking for some third side. Well, let's assume that the 5 is the shortest side, the 13 is the medium side, And this unknown is my longest side. Well, doesn't that mean that 5 plus 13, according to my rule, doesn't it be greater than this missing side? So doesn't my third side have to be less than 5 plus 13 is 18? I know my third side has to be less than 18 inches long, right? Now, what happens if, instead of that, what happens if I mix things around? What if I have this 5 inches as one of the sides? He could not, 5 can't be the longest side, right? Could 13 be the longest side? Oh, that could happen, right? So if he's the longest side now, right, doesn't that mean that this 5 plus this missing third side would have to be greater than 13? Well, doesn't that mean if I, wait, isn't that third side like a variable? Couldn't I subtract the 5 across to figure out what that third side would have to be? Well, if I do that, I get my third side would have to be greater than 13 minus 5 is 8. So ultimately what that means is, I know that 8 has to be smaller than the third side, but the third side can't be, it has to be less than 18. Okay? Now let's take a look at this. I showed you the work on how I got my answer, but is there a quicker way of doing this? Well, here's basically what you think about. If I take the 2 lengths that are given, what's 5 plus 13? 18. Does everyone see that the 5 plus 13 equals 18? That's how you get the bigger number. And then what's 13 minus 5? 8. The smaller number. So if you just take the 2 numbers that are given and add them, that'll be your uppermost length. And if you subtract them, that'll be the lowermost. So let's do this one more time. In example B. What if I gave you these lengths? What if I gave you 17 centimeters and 28 centimeters? Well, I know that my third side would have to be between, and that's how we write between in math, these 2 lengths. Add together, well, 17 plus 28 is 45 centimeters. And 28 minus 17 is 11 centimeters. I know that that third side has to be between 11 centimeters and 45. 28 minus 17, 28 plus 17. Okay? And those are the inequalities that we have in this section. Bye.
You know what?